Okay, so have you ever experienced that pure thrill of vibe coding? You know the feeling, right? You type this incredibly clever prompt into an AI, and suddenly, it just spits out magic. Honestly, it feels like you've unlocked the secrets of the universe in a single chat window. But then, you take that impressive little demo, you try to plug it into your actual real-world operations, and bam, it hits a wall. Usually right when you're trying to show it to your boss. It starts forgetting things, it completely invents data, and under any real pressure, it just falls apart. Well, if you've ever felt that relatable frustration of your AI plateauing, you are in exactly the right place. Welcome to this explainer. Today we're going to break down exactly why those demos fail and what you actually need to build systems that, work. We are moving beyond prompting and diving straight into the architecture of context engineering. So here's our quick roadmap for the explainer today. We'll start with number 1, the limits of prompting. Then 2, enter context engineering. 3, the key differences between the two. 4, some real-world business applications. And finally, 5, the AI maturity curve. Now, I really want you to think about this quote for a second. Prompt engineering optimizes what you say. Context engineering optimizes what the AI knows when you say it. This right here, this is the core thesis of our explainer. We're really trying to transition your mindset today from simple prompting tricks to complex, enterprise-grade systems architecture. Because it's not just about asking the right question anymore, it's about engineering the entire environment of information surrounding that question. If you take literally nothing else away today, please remember this fundamental distinction.
All right, let's jump into section 1, the limits of prompting and exactly why vibe coding plateaus.
To figure out why casual vibe coding eventually hits a wall, we kind of need to define our baseline first. So, prompt engineering. Basically, it's the skill of writing instructions that guide a large language model toward a specific, high-quality output in a single interaction. It was one of the very first practical skills we all picked up when ChatGPT and Claude first dropped, right? It relies on fast, low-cost techniques, stuff like being highly specific, providing examples, which we call few-shot prompting, or forcing the AI to show its work with chain-of-thought prompting. And hey, let me be totally clear here. For a single self-contained task where the model already knows everything it needs to know, prompt engineering is absolutely fantastic.
But here is the absolute brick wall. The limit. No matter how beautifully well-crafted your prompt is, it literally cannot manufacture information the model was never given. Simple prompting breaks down the very second your system needs to, say, remember a past interaction, or pull live business data, or coordinate multiple steps in an operation. Think about it. You can't just prompt a model into knowing a customer's live order status if you haven't actually connected it to the database. It's just going to hallucinate a fake tracking number, and that is going to ruin your day for sure.
Which brings us right to section 2. Enter context engineering, designing the full information environment.
This is the real game changer. This is where we shift from just tinkering in chat windows to the actual business-critical discipline needed for true reliability. Let's look at this definition back-to-back with prompt engineering. Context engineering is designing the entire system of information, data, memory, tools, and instructions that an AI application uses to reason reliably over time. Notice the shift in language there. We aren't just writing instructions anymore. We're stepping back and engaging in a much broader discipline of systems design and data architecture. It asks a much bigger question. What is the full set of information this model needs, in what exact form and at what exact moment to make the right decision?
So what does this actually look like? Think of this as your architectural blueprint for a production-ready environment. First, you've got retrieve knowledge, pulling in documents dynamically using RAG. Then there's memory, keeping track of interaction history so your user doesn't have to repeat themselves 50 times. You have tool outputs, which feed the AI real results from APIs and live databases. You've got the system state, so the AI knows exactly what stage of a workflow it's in. Then, you still have structured instructions. This is actually where your prompts live, just as one layer among many. And finally, context window management. This is absolutely crucial. It's carefully deciding what to compress or leave out entirely so the AI model doesn't just get overwhelmed by a bunch of irrelevant noise.
Moving on to section 3, the key differences. Let's do a head-to-head systems comparison.
If we put these two side by side and bounce between their scope and failure modes, it gets pretty clear. With prompt engineering, your scope is really just a single interaction or a single instruction. But with context engineering, the scope is the entire AI system and the entire data flow. And look at what happens when things go wrong. If you mess up your prompting, the failure mode is a vague, maybe inconsistent output. Actually, scratch that. It's annoying, but usually pretty harmless. But if you ignore context engineering, your failure mode is lost context, completely unreliable behavior, and massive hallucinations at scale. So the big takeaway here is that every good context-engineered system still needs well-written prompts, but a clever prompt can literally never substitute for a poorly engineered context. And when you look at the skills needed, it's a completely different ballgame. Prompting relies super heavily on writing, reasoning, and just rapid iteration. It's essentially a communication skill. Context engineering, on the flip side, demands a really deep understanding of systems design, software engineering, and data architecture. Because of this, prompt engineering is your go-to for prototypes, one-off tasks, simple personal assistance. But the second you start building production AI agents, copilots, or serious enterprise workflows, that is where context engineering is totally non-negotiable.
Okay, Section 4, Real-World Business Applications, or how we actually move AI from those flashy demos to real working production.
Let's look at how this plays out in the real world, because this is how you avoid those disastrous AI failures making headlines. Picture this scenario. A customer support AI is trying to help a really frustrated user, but it completely fails to see the customer's recent order history. Now, in the early days, a developer might try to fix this by just going in and rewriting the prompt, maybe adding, "Hey, be sure to check the order history," in all caps. But that's not going to work. It isn't failing because of a bad prompt. It's failing because it was never actually given the context pipeline to see that data in the first place.
Or imagine a financial assistant giving a user completely outdated compliance guidance. Again, you cannot prompt your way out of this. You can't just tell the model, "Be more accurate." It's not a prompting problem at all. It's a context freshness problem. The model is just relying on static training data instead of a dynamic, real-time data pipeline. Fixing these kinds of issues requires that business-critical discipline we talked about, engineering the whole environment, not just tweaking a couple sentences of instruction.
So what's the actual toolkit that big companies use to solve these exact failures? Well, they use RAG, Retrieval Augmented Generation, to ground AI responses in company-specific, totally up-to-date data. They implement these persistent agent memory systems, so an assistant remembers who you are from yesterday's session without making you explain the whole situation again. They use tool and API orchestration, which lets the AI actually pull live data or even trigger actions inside existing enterprise software. They meticulously filter data through context window optimization. And they build multi-agent architectures. That means different AI agents are engineered with distinct, specific context instead of just relying on one giant, messy prompt that's trying to do a million things at once.
Finally, Section 5, the AI maturity curve and how to scale this successfully.
So we've talked about the what and the how, but let's talk about the when. How do these concepts actually build on each other as a business scales its digital product strategy? Look, this isn't an either-or situation. It's an evolution. In step 1, the early prototyping stage, using just prompt engineering is totally fine. You're just testing what's possible, moving fast. But in step 2, the second you start scaling to real users, context engineering becomes absolutely essential. You suddenly need those retrieval systems so the AI doesn't lie to your customers. And then in step 3, for true enterprise-grade systems, both of these disciplines literally have to work together perfectly. Prompt engineering shapes how the model reasons, while context engineering ensures the information it's reasoning over is complete and trustworthy in the first place.
Look, treating AI as a strategic, long-term capability isn't something you just hack together on a Saturday afternoon. It requires serious platform engineering and cloud-native architecture experience. And this is exactly what teams like 200OK Solutions do. They help businesses move past that basic AI experimentation phase by architecting the complex data pipelines, the memory layers, and those deep enterprise integrations that are required to make AI genuinely reliable at scale. They combine deep engineering expertise with really sharp product thinking, so your AI isn't just a cool demo, but a transformative tool for your business. Which leaves us with this final thought to reflect on today. Take a hard look at your own digital product strategy right now. Are you just building an impressive prototype that relies on some clever wording? Or are you architecting a reliable, production-grade AI system that's grounded in rock-solid context engineering? Because I promise you, the difference between the two is the difference between an AI that merely talks and an AI that actually works. Thanks so much for joining me for this explainer, and I hope this really helps you go out there and build smarter, more reliable systems.